Okay, guys, so let me start the lab today. So I think last week, so what we did yesterday, what we had done, guys? So this is the access list, like where
to make it better for.
So what is yesterday we had done standard access list, extended access list. Okay, and some of we are not getting the proper exact answer, right? Isn't it? Okay, so we'll do right now. We'll start today. We'll start with ACL labs. Okay, so ACL labs. First, we'll start with standard. Okay, standard ACL, extended, ACL, and your named ACL. Okay, and named ACL, guys, again, you will be having extended and standard. Okay, no difference. Just thing is, just we need to see how does configure. Just we need to give name. Instead of giving the number, we can give the name. Name with the number also we can give. Okay, so as soon as complete this topic, guys, so literally I'm going to start the NAT today. So I think you might heard about the NAT, right, guys? So NAT is nothing but your network address translation. So we are also going to start your lab for this. That is your static NAT. Okay, and dynamic NAT. Okay, and PAT with the port address translation with the PAT overload. Okay, so these are the three we'll do it. Okay, this is the today's topic, guys. Which are the things what I have written there? So these are the today's topic. So a lot of lab, guys. You have to pay some attention. So we'll do right from scratch. Once I had done this, all the lab, because in NAT I'm going to explain very simple way. Okay, so NAT, as you know that, so it will be applicable only for IPv4. Okay, this is what I'm going to discuss today, guys. So after this, guys, again I'm going after this, if we have time today, so we shall also discuss with other topics like security, network security, or I will jump for IPv6. Okay, so because in IP I'm going to start some of the, I think especially Pawan, he was not there, so I want to repeat this IPv4 for the few other guys. Okay, this is the today's topic, guys. I'm going to discuss. If you have time, we'll jump for the new topic. Let's see how long it takes time for this all this NATing, dynamic NAT, PAT, overload, standard, access list, name. Okay, these all labs will do it directly. So we'll today I'll not teach you the any theory part. So we shall do only labs. Okay, guys. So let's start. So I have already opened the packet tracer, so you can see what I am going to do now. So I'll open the topology, guys. So topology, I'm going to use the same one. So let's say yesterday what we did. I think this is a topology, so which we have configured. What are the things we should check here? Right now, I'm going to explain, guys, standard access list. Remember, guys. So this is the lab for your standard access list. Remember here. Standard access list. So it should be configured nearest to your destination. Understood, guys? Please pay some attention, guys. Okay. So yes, what is the objective for this lab? So what could be the objective for this lab? is these guys. So we can see this PC, this laptop, okay, which has got 1.2 PC, 1.2 IP address, and this PC has got 1.5. Should be denied to access my 2 network. This network. What is this network? 2 network. When they are coming to access this guy, okay, he should get deny. Deny or block. Understood, guys?
Yes.
This is a task 1. And second task is this network. This is my pink color. What you got? Network. When this guy was trying to access this network, it should get blocked. Block or deny. This is the objective for this lab, guys. Okay, so let's do that. So before that, guys, so what is the first task we should do? All people, they should communicate with each other. So first tell me, like, how many networks are there running in this this thing, guys? This is my network 1. Okay, guys, blue color, yellow color network 2, green color network 3, and this pink color 4, and this is like one more pink color is 5. So total 5 networks. Which all the networks I am running? So this is my 1.0 network, okay, 10 network, 20 network, 2 network, and 3 network. So totally 5 networks I am running here. Okay, so what are the best things what we should configure here? They should communicate to each other. So everybody, they should have a communication before applying your ACL. That is your standard. Now, so they should communicate. Let's first check the communication, whether they have the communication to each other or not. Okay, first check what are the things I have configured. So I'll put it like this. Show IP interface brief. So right now, guys, step by step, I'm repeating the same lab yesterday what I did to you. So this is 1.0 network I'm running, and this is serial interface. This is a WAN interface, right? Okay, and I have created 2 loopbacks. Right now, I don't want to use a loopback here. Okay, if you check whether any routing protocol it has been configured, show IP route static. Okay, so static routing is working here. They have the communications. If you check this one, so I can reach to 192.168 2.1. Fine. So even I have the communication for your 3.1. In 3.1, so I can reach to any PC. Yeah. So 3.3. Now they have the communications. Or else we can check directly from here. Take the PDU. So let's check whether this deny these people they have communication. The first packet will be dropped, and now success. So do they have the communication? Laptop to laptop. 1.2 to this piece laptop. Yeah. So we have the communication. So everybody they have the communication to each other. Let's check this laptop to this laptop. Yeah. They have the communication, guys. No problem. Show IP route static, because you know static routing I have configured. I think you know, right, how to configure the static routing. All of you, right? Which I already explained. So this guy is running all the routes. We can able to see it. So let's check the last router now. Show IP route static. So this guy also learned the static routing. So ping 192.168, I can reach to 1 network, right? So even I can reach to 1.5. Okay, even I can reach to 1.2. Okay, they have the communication, no problem at all. Okay, so now I'm going to configure your standard access list. So what is the standard access list? It should be number with 1 to 199. You should configure nearest to destination. Okay. So now the objective is this PC. Okay. What this PC available is 1.5. Okay. And 1.2 should be denied to access my 2 network. This is my 2 network. Same thing, this guy also. Fine.
Sure.
Okay, same thing. Now, right now in this scenario, we have what we did, just one PC. Even this 3.0 network, this is entire network, we are not allowed to access our network. Say example, this is your security department. So example, this is your cyber security department. Nobody are allowed to access. Even we will do block for this network, but this server can able to access your network. These guys, this guy can access. Only these people should get blocked. Should get denied. Okay, so let's do that. So which router I should configure, guys? So which router I should configure?
Router number 2.
Router 1 or 2?
2, sir.
Yes, very good.
The
It should be
router.
maybe
Router, the middle, at the middle. Right, router 2.
yes, router 2. Yes, good. So what I'm going to configure? So go to global configuration mode, access list. Okay, let's say I'll give 10. Means the 10 means that is standard access list I'm going to configure. Deny. Okay, what I want to deny? I want to deny these 192.168 1.5. Right? 1.5 is what? This guy. Can you see? 1.5. Okay. And you can give any mask, no problem. Okay. I also want to deny access list 10, deny. Okay, which I want to deny this host as well. Which is that host 192.168 1.2. Okay. And one more is I want to block your router 3 network. Access list 10. Okay. Deny entire network 192.168 3.0 and give the wildcard mask. When you are going to block the entire network, so you must give the wildcard mask. And remaining other people let communicate. Okay, access list 10 permit any. This other people they should able to communicate. Okay, done. Now I'll go to gigabytes interface. So what I'm going to do now? So I'll go to this interface. Which interface? Yeah. So gigabytes 0/0/0. I will apply as an outbound. Fine. So IP access group 10. Okay, that is out. That's it. We have created the access list. We have applied to the interface. Just save it. So as you can see, we have done this. So how to check the access list? Show IP access list. So we can see right now. So we have configured. We are deny 1.5 and 1.2 and 3 network as well. So let's check this one. How to connect? How to check this? First, check for these guys. Is it we update the interface? Check with this guy. So this guy has blocked. You can see, right? So this guy has blocked. So he cannot communicate to this network. So let's check this guy. 3 networks should be blocked. He cannot access to any PC, laptop to laptop. They cannot communicate. 1.5. I think this guy, I think what IP address we have given. Yeah, this guy is also now is getting blocked. Okay. Let's check 1.5. Is it we have given 1.5 host deny. So let's check whether this is proper IP address. Check what is the IP address for this guy. Oh man. What is the mistake, guys?
The IP address.
This is 1.4 has taken. Now check me who is 1.5. Yeah, this guy is 1.5. So what we should do, guys? Just replace these to this. Alas, correct? Now this guy should not access this one, right? So let's check this one. Perfect. He cannot, this guy is blocked. What about this guy? This guy should communicate, right? Yes, perfect. And server to server, yes, do they have the communication? Perfect. Let's speak once again. Yeah, they have communication now. So what about these people? So this network cannot access to any network. Say server to server, they can't because we have blocked. Server to this laptop, no communication. Perfect, guys. So now it's working.
Down a bit, I want to see the configuration on the interfaces. For...
Yeah, I'll show you that. Okay, show run. Okay, so this is the configurations what I did for your standard access list. This is your standard access list. Standard ACL. So with that the number I have given 10. See right now what is the topology? Sorry. The thing is access list 10 I have given. Deny. Okay, fill is 1.5. Okay, and 1.2. These two hosts I have blocked. Okay,
Yes.
so actually topology how it is if suppose if you check. So let me show you that. This guy is blocked and this guy, this PC also blocked. Okay, these people, they have the communication. Imagine this is your cybersecurity department. Okay, when this guy trying to access any one of the PC in this network, so it should be denied. Deny or block. Same thing here. This also guy should be denied or block. When this guy, any one network, any one of this network, if they are trying to access this network, should be denied. Deny or block. The command what I have given here in the router 2, as you know that, okay, your standard access list will be configured nearest to destination. Correct. Standard access list. Okay, as per this one, this is your destination. When this guy is coming, if this guy is coming to access my network, I'm going to block. When this guy is coming from my network. Got it? So let me explain one other way of concept, guys. So most people will do mistake here.
Okay, so I understand the concept, but I want to see the actual commands on the interface.
Yeah, I will tell you that. I will tell you that. See, first, guys, understand the topic. What I want to give some important emphasis, guys. The traffic which is coming to the router, First, understand this first. The traffic which is coming to the router, that is called inbound. Got it? The
Yes.
traffic which is coming out from the router, what is called outbound. Fine. Same thing here. The traffic which is going out from the router will call outbound. The traffic which is coming in to the router will call inbound. Now, so as per this in gas in the real time, because as I told you that your ACL can be configured on the firewall, okay, any firewall, maybe Palo Alto, Firepower, or FortiGate checkpoint. It can be configured in firewall as well. Okay, recommended. As you know that what is the name of this link, guys? What is the name of this link? Andrew?
It's a serial link point to
Isaac?
point.
Isaac, what is the name of this?
It's a one link.
Yes, very good. This is the WAN link. This is called WAN link. And what is this link, guys?
LAN.
LAN link. See, ACL applying to the
LAN link.
interface, okay, applying to the ACL is not recommended for WAN link, guys. Not recommended. Remember this. It is not recommended by Cisco itself. Okay, better to apply for only for your LAN interface. What happens sometimes? The network which is, if this guy should able to communicate to this guy, right?
Mhm.
And that guy will get blocked.
I see.
Let's see here. Say example, server to server. They have this thing, right? Communication right now. Right now, we can see they have the communication now. Okay, it's not recommended to configure on your LAN interface. Any LAN interface is not recommended. Recommended for only for your
LAN.
LAN interface.
For both extended and the standard, or for only standard?
Both.
Okay.
It's for both. Okay, extended or standard. Recommended is for only for your LAN interfaces. Because what happened? Because if you apply here, okay, other traffic, maybe you're running other router here. So this guy cannot access to this network if you apply for your WAN link, ACL, if you apply here. So this network also get blocked. Maybe, and this is your ISP router. So this router will take you for your internet access. If you apply this this WAN link, so these people, they cannot access your internet. That is a problem. That's the reason recommended is for your LAN interface. Understood, guys?
Yes.
Okay, so Claire, I want to show you the command, right? You want to see the commands. So this is the command. So what I have given here. So anyhow, I'll send you this file right now. Any question, Isaac?
No question.
Sahil, Gani, Pawan,
Sir.
Arthamayinda?
Yeah, I understand, sir.
Asma, did you understand? Fine. So let me send you this file as now, right now. I'll save this file.
Thank you.
You can,
Thank you.
You can check from your end. So this is standard ACL. So please download from your side, guys. So both the file I have shared you. So you can go ahead and configure from your side. So now I'm going to jump for your extended ACL. For extended ACL, guys, I'm going to use the same topology. For here, guys, first you need to understand some. Let me open my extended ACL. So I'm going to use the same topology, but here the scenario is slightly different than your these things. Check what are the task I'm going to do. So this is the task, guys, here. The task is here. Guys, pay attention, guys. The ACL is very important. So as I told you that it can be configured this way any firewall. So firewall will happen local or is placed on the cloud. Doesn't matter. The configuration is quite very same. So this is your extended ACL. So what is the extended ACL? It should be configured nearest to where? Nearest to source, right? Starts from 100 to 199. Correct, right, guys? Okay. So as per this topology, so assign the IP address, configure DHCP, create some loopbacks if you want. Telnet also not required right now. Will not do the telnet. If you want, we can do the telnet, no problem. Configure any static routing. So then the task is that this is a two task. So what is this? What is this two task is? So deny two network should not access to 1.4. That is HTTP server. Okay. So who is HTTP server? This guy. That guy, not this guy. So let me show you that. Yeah. So this is your HTTP server. This guy. So this guy is your HTTP server. This is 1.4. 1.4. And second task is, let me show you this. You can see. So deny 3.2 should not access to 1.3 HTTP. Okay. Same thing here. Before I jump for this one, what is talking about 3.2. Okay, 3.2 is this PC, I think. This PC. This is 3.2. So this guy should not access to this web server, that is 1.3. Same guy. 1.4, I guess. This is the 1.4. By mistake, I think I had given. Means we are not, what is the objective for these guys? Very simple, guys. So this is our web server. Imagine this is your company web server. We are going to do what here? I am going to explain. So any one of these PC should not access to our web server. Access to our web server. So example, this is my Dell company. Okay, this is my Dell. Okay, this is our web server. If they try to access our web server, so we should deny this guy. Okay, it should be configured where? It should be configured nearest to where? Where I should configure?
Configure nearest to source.
Source. Very good. Okay, guys, you have to remember some of the standard port numbers. Okay, I think you might know about the port numbers, right? So what is the port number for FTP, guys?
100.
100? No. Okay, you tell me what is the port number for Telnet? For FTP is 20.
20.
Okay, and FTP controller,
21.
FTP control is 21.
21.
Okay, for telnet is 23. For SSH, what is the telnet?
22.
Yes, very good. Then for SMTP
SMTP.
is a port number 25. For DNS 53, I think you know, right? DNS. Your DNS is your port number 53. Because you know, when you're going to configure your extended access list, you should know some standard port number. I'm not telling to just memorize all your routing. This one port numbers is difficult. Some standard port numbers, what I mentioned here. So you should know, guys, this one port number. So what is the port number for UDP? So UDP has got this one, guys. UDP protocol, it has got 3 tabs: DHCP server, DHCP client, okay, and TFTP. So UDP, it has been classified into again 3, right? I think I told you, right? That is your DHCP client, okay, and DHCP server, and one more is your TFTP. And all the for this is start from your 67, 68, and 69. We have to remember, guys, this one. If you don't remember, guys, just Google it. You can find a lot of port numbers, like standard port number. Okay, let me show you that some standard port numbers. So if you check in paging all in that, so I think we can able to see. So let's open this. Okay, we can see, guys. So these are like standard port numbers where we can able to see. I think you can able to see, right?
Yes.
Right. So these are the port number, guys. Like if you want, I will share you this link. Okay. You can able to. You can see, right? For every protocol, guys, you will be having some standard port numbers. So I'm not telling to just remember all protocols. See, for the echo, we are using port number 7. These are the standard port numbers for TCP and UDP, guys. Remember, these are all the interview questions. So most organizations, they ask, they will not ask entire thing, most standard protocols. See, Tivoli file transfer protocol is for transferring the files. 69, as I told you, DHCP 66, 67, 68, 69. Okay, for HTTP port number 80, Kerberos 88, Microsoft Exchange 102, POP3. POP3 means, what is a POP3, guys? What is the meaning of POP? POP3? Post Office Protocol. Post Office Protocol. Same thing for the TACAS, Radius, DNS 53. Okay, 2021 for FTP. So we can see guys for the LDAP, for FTP, IMAP, Post Office Protocol. And see, these are the few application classes like Google Desktop. So these are standard. I think you should remember a few basics things. Not entire thing is difficult, I know.
Sorry.
Yeah.
When you say port number, what does it mean?
Port number is nothing but your house number, man.
It's like your host number.
House number.
For example, in the router, the default router is like 192.168.1.1.
Okay. See, guys, it's very simple. This question, who asked this question? Andrew, right?
No.
Who was this question?
Isaac.
Isaac. See, Isaac. So ISSEAC, right? Okay.
Yes.
I have ISSEAC 2 people now. Okay. I am sending you some parcel. Say example, I will send you one laptop to you. This is my HP laptop. I want to give gift to Isaac. Okay. So how it will reach to you guys? Okay. So right now you are in. How do I write my email address? How do I send this? Okay, you will be having 2 address right here. I'll write
House
Isaac.
number.
Okay, everything house number, you will write their name like exam Malawi, okay, Africa. Got it?
Sure. Yes.
Okay, I'll pack this one in the box. Okay, I'll write all the packs, I'll label in this box. I label here. Okay, and I will send to the DHL or any international courier services. So these people will reach according to this address. You know what is
Address.
what kind of address it is, guys? This is logical address. Correct?
Yes.
And this is your physical address. This is all the physical address. Correct?
Yes.
When the DH guy will come to reach to you, okay, so as I told you that, so you are in different country. Okay, he'll read this address. So this guy, the guy who is the delivery boy, okay,
Yes.
he
From
will
DHL.
he'll reach to you. Now he noticed that he has there the 2 Isaac is there here in your street. Say example, this is your street number 18th cross. Okay, and some numbers, this some layout near some church.
Sure.
Okay, so now when this guy get confused, now to whom to deliver this laptop, I can see both Isaac side by side. You understood, guys?
Yes.
Then, as you know that, so far when I write these things, I must have your door number or house number. So example, okay, so for Isaac door number, this Isaac door number is 11 and this Isaac number is 12. So what is I want to deliver for the only Isaac 12. So this guy will see this logical address where it has mentioned the house number is 12. Then he will deliver this laptop to Isaac.
Okay.
Now this number is nothing but your port number. So port numbers, it will work in which layer? Transport layer. That's the reason transport layer is one very important. Okay, it is used for the reliable communication. Understood, guys?
Yes, I understood.
Okay. So let's jump back for this lab now. So now this is the task, guys. So right now we can see, so what is this I'm going to do? I am going to configure your extended access list. To configure the extended access list, okay, so which router I should select, guys? Where I should configure?
Yeah, to the source.
Nearest to the
Source.
Okay, who is the source now?
Alto.
Router 1, right? Router 1 is the source, right?
Sure.
Correct. So show IP access list. So no access list. So show IP route. So right now I have configured with the static routing. It's already configured static routing, but first remember before configuring the access control list, they should communicate with each other. So we can use any dynamic routing or any static routing. Right now I have configured with the static routing. So we can go ahead with static routing. Already have configured it. So now I'm going to configure your standard access list. Okay, so let's configure this. So what I'm going to do now, so as per our scenario, say, so this network, so this guy should not access to our web servers. Let's see what is the web server IP address. This is 1.2. Wrongly we have mentioned. Okay, this is 1.2. And here also task also we should change. So actually task is deny the user 2 network to access our 1.2. 1.2 is our web server, guys. Remember, this is our web server. This is our web server. Okay, so let's configure this. So what I'm going to do, so I'll go to global configuration mode, access list extended. Extended means we can give more than 100. So I'll give 110. Okay, I say deny. Okay, which topic is that? It's a TCP traffic. If you give the question mark, so it will show you the list of command, which one we have to use it. So right now, what kind of traffic that is? Remember, guys, all the internet is a TCP IP traffic, guys. Remember, whichever the communication happening right now, we are communicating that we are using the Zoom application through internet. We are connecting to each other for this training. Okay, so here also we are using the TCP IP traffic. So what kind of traffic it is a TCP traffic. Okay, so what you want to do? I want to deny. Okay, which network? Which network I want to deny? Which one, guys? I want to deny this 192.168.2.0 network. Okay, give the wildcard mask. Okay, which host you are going to block when they are going to access my web server? What is my web server? 192.168. 1.2, right? 1.2, right?
Yes.
Okay. Now give the question mark. Now he's asking this all the description equal to, not equal to, less than, separate reasons, range. Right now match, equal to. Let's say equal. Give the question mark. So what you want to try to do? I want to block my www World Wide Web. We can give HTTP or port number 80 also we can give. So I'll give www. Okay, so now I have blocked the two network. Two network cannot access my web server. Right, as per the first scenario, what we did there. Understood, guys?
Yes.
Okay, so what is next task? What is the next task? I want to block this guy also. In second task, so 3.2. Let's check who is 3.2. 3.5. Yeah, this guy is 3.2. This guy. So this guy should not access to our web server. Yeah, so how do I do this? Okay, access list 110. Okay, deny, same TCP traffic, right? Same TCP traffic. So now, okay, so what I want to deny?
192.
Give the host here. We are going to block only single host, right?
Okay.
Okay. Other guys, they should communicate. Other people, which all are network, other like we have the laptop server, they should communicate to the server. Only 3.2 we are going to block. That is a single host.
So if you write the only IP, it will block all.
All, yes. Be carefully, because don't do this experiment unless you have do the lots of hands-on experience. That's the reason always I'll ask you, please do practice. When you have the job in your office, in your organization, in your company, so don't do experiment there. There might be chances to entire network will go down.
Okay.
No communication is very dangerous ACL. Okay. Right now, what we are going to do, we are going to block only one single host. Okay. What is that host name? 192.168. That is 3.2. Correct. 3.2. To which host? Single host. Only 1-to-1. Correct.
Okay.
Okay. Single host. Give the question mark. Destination. Now he's asking destination. To whom you want to block? I want to block 192.168 1.2. Okay. What do you want to block? Equal to like telnet FTP, okay, www, or even we can give port number 80 or HTTP. I'll say this time I'll give port number 80. That's it. So just we have created the ACL. Got it. Now you tell me which interface I should apply. Better to go for your LAN link, as I told you that. Okay. So interface gigabyte 0/0/0. Okay. So IP access group is 110. So previously we have created the ACL. Now what ACL we have created, that we have to apply for the interfaces. This is how it will manage your traffic. This is your filter your traffic. 110. Then and one more command we have missing, which is quite very important. You know what is that? Access list 110 permit IP any. If you're not given this command, what happen? All people will get blocked.
Okay.
Right now, only one network and one PC we have blocked. That's it, right?
Yes.
Okay. So let's do that. So now I will go to the gigabytes 0/0/0. So IP access group. Okay, 110.
Deny.
Okay. What is the inbound or outbound?
That is inbound.
It's outbound, man. How it is inbound?
No, yeah, it's outbound, sure.
Should be
sure.
outbound because you're doing it from the source.
Yes, it's outbound. That's it. There. So let's check the connectivity now. So what we did now, first understand, I have used the two commands. So this is my 3.2. Okay. This PC, when he's jumping these two routers, okay, trying to access this guy. So here is get denied. When this guy is coming, this is the number one. Second one, if any one of this PC, okay, try to access our web server, they are coming via same router 2 and this way, they are also getting denied. This is what we did. Understood? This is
Yes.
our web server. So let's check the result now. So let's go to this PC now. So HTTP /192.168. What is that? 1.2. Yes, we cannot access. So can they communicate? Ping 192.168 1.2. Is it correct, guys?
Going through.
Is it correct? What we did?
Correct.
Is it correct or not? Tell me fast. Is it correct, right? We have blocked only HTTP traffic, only internet traffic, not telnet or not echo, ping, ICMP traffic. This is ICMP traffic, right? Ping command use ICMP protocol.
Yeah.
But
How can we check that the HTTP is not working?
yeah, here now go to the web browser. Okay, HTTP:// give the server IP address 1.2. Here, press enter. You cannot access. It's getting blocked.
Okay.
We cannot access. See, if I type go request timeout, can you see?
Yeah.
Now, what about this PC? Say example, this PC, they must access, right? Web server, HTTP://192.168.1.2. HTTP. Timeout. Do they have the communication? So 192.168.1.2. Yes, they have the communication, but they are blocked.
Mhm.
Right. So this PC, we have blocked it. What about this server? Server to server communication, let's check. HTTP://192.168.1.2. Yes, these guys, server, they have the communication now. They have the communication. Now, this laptop also has got communication now. HTTP://192.168.1.2. Got it? Means this guy got blocked. But they can communicate to each other, guys. If we check, everybody, they have the communication. Say this server to this server, they have the communication. Can you see? Everyone, they have the communication now. You can see, right? So every guy, they have the communication with a server. They can send, they can communicate with each other, but not internet. And this server to this server, yes. Then what we did now? Understood, guys? Guys, you understood?
Yes.
Okay.
Yes, Clara, do you have any question?
I think I'm a bit confused on the rule that we're saying we need to configure the extended access list on the where it's nearest to the source. What does that statement mean? Because I think I understood the other one that we said nearest to the
See,
destination.
Extended access list should be configured nearest to source. Okay, this server is a source. Source to this all network, this network and this network. Whenever these guys coming to access to this server, and what is this one? This is this guy became, when this guy is coming to access this guy, he should get blocked. Same thing here also. When this guy is coming to access to this network, so we are getting block here. So as per the extended access list, you should configure nearest to source. This is the source. That's the reason we are configuring in your router 1. Understood? Clear? This is my router 1 where I configure my, as per this, this is the source, right?
Which is the source? The server?
Hmm?
Oh, okay. I thought the server was the destination IP. I think that's why I was confused.
Yeah. Okay, next come to this one, guys. One more lab, which I want to tell you this one. Okay, extended named ACL. So named ACL is very simple. Just we need to give the name instead of that one. So we can give your CCNA with the number, say example 10. 10 with the CCNA. So one of the PC you want to block. Remaining configuration are same, previously what we did. So I want you people to do this lab, guys, especially for your named ACL. You'll do, guys, so that I can jump for NATing and PAT, NAT and PAT, network address translation. Or you want me to do this one, named ACL?
Which PC enably can be used to standard and extended.
Yes, named access list can be configured any extended or standard.
Okay.
No problem. So we can configure any one of this one. If you want, I'll show you one lab so that I'll show you the lab for standard ACL for these things. So let's say, let me send you this command, guys, before because you know this command is also very important for you guys, right? This one is extended. Yeah, extended text file. Better to send first. So I'll send you right away. Okay, I have sent you, guys. So please check from your side what just lab we did just now. So I shared you. So we can train from your side.
Okay.
Got it, right? Because I want you people to do the named ACL, guys. You will do or shall I do, guys?
We will do.
You try, you guys. Just we need to give the just name. That's it. Nothing else. Remaining all are same.
Sure.
Okay. So just we need to go. Just we need to add just IP access list. That's it. Instead of access list, just we need to add the IP access list. There's the only difference. If you want, I will do the same. What I will do means the previous lab what we did. Say example extended access list. I say copy and paste the same one, and I say named it. Named extended ACL. Okay, so this is the lab. I think what we did. This is the extended access list, right? So how to remove, guys? Access list.
With no.
Show IP access list. Okay, go to global configuration. No IP access list. Extended. No access list. I think that's it.
Yeah. Okay.
Okay, show IP access list. Now it is removed, right?
Yes.
Now it is remote, that's it. So now I'm going to configure your what? Named ACL. Same scenario, guys, what we did here, same scenario I am going to do for your named ACL. Okay, let's change this to okay, named extended access list. Guys, you are following, right? Is it ACL is interesting, guys?
Is.
Clara, Andrew, Isaac,
Yes.
you're following, right? Because I'm putting a lot of effort, you people, guys. Clara, Isaac, Pawan, Andrew, Angie,
Yes,
Clara, Asma, Sahil Gani.
Yes.
You're following, right?
Yes.
Yeah. Okay.
Yeah. Okay. See, guys, so as you know that you should configure here to the source. No, I'm going to configure a named ACL. Go to global configuration mode, IP access list. Okay, give the question mark. Okay, if you type IP, so previously how we are giving access list directly. If you give the question mark, it will ask you the number. Correct. Previously it was asking like this, right? Now it's not like that. So now IP access list, give the question mark. So what you want to do? I want to do the extended access list. You give the question mark. We can give the extended number or name. Say I am going to block so block HR. Okay, one of the HR network I am going to block. Okay, which is not good, right? These are the people who will give the job for us. And remaining all commands are same. So I think you can just deny. So what you want to deny? Same command. So what are the commands? Deny TCP 192.168.2.0 network. Okay, so give the wildcard mask. Okay, then which host? Same thing, server, right? What is server IP address? 192.168.1.2. Okay, equal to www. That's I will do only one, guys. If you want second one also, we can do it, no problem. Okay, just thing is just we need to give the same one single host. Okay, let's do that one also. TCP. Okay, then give the question mark. I want to block one host. That host is 3.3.2. Sorry, 3.2, right? 3. Single host. Okay, give the question mark. Okay, he's asking to which PC you want to block, to whom you want to block. That is 192.168.1.2 is our web server. Equal to your www. Or we can give the port number also, no problem. Okay, then what is which is a very important command? IP permit IP any. That's it. So just now we have created access list. So
Yes, sir.
yeah.
Why are you writing any? Means you allow the IP addresses and the network.
Yeah.
Okay.
See why I'm doing permit. Okay, give the question mark. So permit what? I want to permit any IP address. Which IP address? Any IP address. Okay, which network? Which destination host? Any host or any destination. That's the reason I'm giving permit IP any. Means other guy they should communicate, right? Just now we are going to block only one PC. Network 2 network, we are going to block to access our web server. And in network 3, so 3.2, we have blocked it. Okay. So now I am going to apply for your interface. Gigabyte 0/0. Okay. IP access group. Okay. So here what I should give. This is important. If you remember the number, we can give the number. Okay. If you don't remember the number, okay, what we can do? Sales, right?
Name,
What is that?
block, HR,
Block. I think
dash,
HR.
HR. Sure.
HR. Okay. BLOCK HR. Correct. That's it. Incomplete command. The word block, give the question mark. He's asking inbound or outbound.
Out.
It's out. And okay, save this configuration, show IP access list. So right now we can see, so we have blocked these 2. Okay, this is them. Remaining all are same guy, nothing else. So let's check the connectivity. Whether this laptop can access my server? No. Check once again. Because only one PC, right? Which is the one PC? I think this guy. What is the IP address for this one? Yeah, 3.2. I think we have blocked only this PC. Let's check. Very success, man. Check. So 2 network TCP is coming to the host 2 network. Is it correct, guys? What we configured?
Oh, I thought the ICMP traffic was still passed through.
Correct. See, what we did is what I did. I'm checking the ICMP. We are not blocked the ICMP. Guys, remember for the ping, it will send the ICMP packets. ICMP is a protocol which is used to connect, check the connectivity between the 2 devices. Okay, how do I check? So let's say I'll open this laptop. Okay, I'll go to web browser. I say http://192.168.1.2. Okay, so we can see I press already entered, so it's getting blocked. Timeout. You can see, right?
Yeah.
But they can ping. They have the communication, no problem. But they cannot access the web server. Same thing, this guy. I think only one guy, I think. Yeah, this guy. This guy has blocked. http://192.168.1.2. Let's wait. So it's got blocked. Yes. Now they can ping it, no problem. I can ping to that server. So 192.168.1.2. So we must have the communication now. Timeout it will come. So next time I hope it will look as yes, perfect. Fine. So this is how, guys, I think they can communicate with each other, no problem. So very simple command I use. This is a command which is there. Okay, if you want, I will save this one. I think already I saved it. I will send this. You want this file also, guys? Okay, named ACL text file. So I will send you this file as well. Named ACL and named named extended, guys, is just do from your side, guys. Lot of things, don't limit yourself, guys. Still, lot of things you should learn. FTP, domain, DNS, telnet, SSH we can block. Lot of things we can do it. If you have any question, guys, you can ask me, so that before we'll start, next topic is your NATing. Any questions, guys? No questions?
Is it? I have a question, Sam.
Yeah.
When
Go
I'm
ahead.
trying to practice packet tracer, I was selecting some routers that do not accept some configuration. Is it true?
Sorry, can you come again?
Sorry. I'm trying to make practice with the packet tracer, I wrongly choose the routers which cannot access some configuration. Is it true?
Yes, some configuration will not work. That's the reason I'm taking high-end router. We can see I will take only 433 router or 4321 router. Whether I use this router or this router.
Okay.
I
Thank
use
you.
always these two routers. Is recommended because I don't want to use the old routers, which has mentioned here. I don't want to use that.
Okay. Thank you.
Yeah. Okay, can I jump for NAT, guys? Network address translation.
Sure.
Do you want break for 10 minutes or 15 minutes?
A break of 10 minutes will be enough.
Yeah, so we'll take 10 minutes break, then we'll continue, guys.
What is the meaning of NAT, sir?
Sorry?
NAT.
Network address translation. I will explain the theory part, some basic theory part. What is a NAT? Why we are using the NAT? So what is the main purpose of NAT? Then I'll jump for the lab. Okay. Yeah. We'll see you in 10 minutes, guys.
Okay.
Guys, I'm back now. Let's start NATing now. Network address translation. Guys, all of you there?
Yes.
Yeah, we are back.
Okay. I am also back.
Okay.
Yeah. So any idea about NATing, guys? Network address translation.
You not, or
Yeah.
I should say, you bind the private IP addresses to the public IP address.
Very good. Perfect. So NAT is also used to convert from private IP address to your public IP. Fine. So what NAT is going to help you? Okay, solve a big problem with your IPv4. What is the issue with the IPv4, guys? Any idea? Okay. So translate your private IP to public IP. Okay, and second one is the IPv4, okay, which we are using right now. addressing space would have been completely consumed by the mid in 1990s itself. We got over. Now, what does it mean now? What does it mean? Because first understand network address translation. So it is the one which we are going to convert from private IP address to your public IP. Say example, this is my router. Okay, and this is connected to your ISP, that is your internet. Okay, and this is my NAT device, or we can say anyone, your router, or even we can say ISP router. So what it does is, as you know that this is, we'll call it as your public IP address. So example, I will take 2.2.45.1.1. So here I'm running my network. Say I have connected some PCs here, some laptops, some servers. Some servers also we can connect. So here, which network I am using? Say example, I am using 192.168. Okay, this is my 1.0/24. So what is this field called? This is your private IP address. So what task it does is, so when you configure with the NAT, okay, we are using this private IP address, which is the class C IP address, which you are using here. It will convert this private IP address to your public IP. With a single IP address, this all people, say example, this is 1.1, this is 1.2, 1.3, and this is 1.4. These all people use a single IP address. Okay, they can access the internet. That is a job of your, it will convert the network address translation. It will translate from your private IP address to public IP. Now, why we require the NAT now? The question here is, why do we require this NAT? Why do we require? Why do we require this NAT, guys? Why do we require NAT? Anybody? Clara, Angie, Andrew, Isaac.
You said that it should translate our private IP to the
Address
public
to
one.
internet address. See. So in the last point, what has mentioned here, see, IPv4 address space should have been completely consumed in 90s. Already the sufficient IP address already consumes. So example, if you see in the throughout the world now, okay, so almost I think 70% people already they are using internet. I think you people agree with me, guys. See, every person, every device, say example, suppose if you take this, I would say 4 billion devices. I'm talking about approximately, I'm talking about the world population, guys. This is the globe. 4 billion devices means all people, they are already using internet, right? They required IP address, right? Without IP,
Yes.
they cannot access internet.
No.
Okay. Assigning the IP address for this IPv4, okay, that is your IPv4, okay, it has got over in 1990s. Okay, the permanent solution for this, we have very less IP addresses. So nowadays, almost 4 billion. Right. So at my home, we can see. So I'm already using 10 devices. At my home, I think 10 to 20 devices I'm using at my home. So all they are using internet. Means every device must have the IP address, right? Of course, even if you configure dynamic IP address DHCP, but still it is not sufficient. The permanent solution for this issue, this is a big, this one guys problem. This is one of the biggest problem for IPv4 because of the less IP addresses. So permanent solution for this one is IPv6. And temporary solution, so temporary solution is your NAT. I hope you understood, guys. So what is the size of IPv4? 32-bit. What is the size of IPv6? 128 bits. So in IPv4, if I use, okay, so one person, he can use up to this number of IP address. One person, which is sufficient, right? That is 100,000 in IPv6. Okay, because the objective is here, I will conclude this one. So we are getting very less IP address in IPv4. Okay, the permanent solution for this is IPv6. And right now, temporary solution is your NAT, what we are learning now. Okay, let's discuss more about it now. So how many types of NAT gas? Any idea? I think I told you about it, right? Difference between public IP address and did I told you, right? So public IP address and private IP address. So this is quite very important to understand, guys. See, your public IP, okay, so used on public network. Which is public network? Internet. So whereas private IP address used within the LAN or with the LAN or within the company. It's a company or in organizations. Second point. Okay. The second point is recognize on internet. What does it mean, guys?
It's not recognized on the internet.
So given by the administrator. What does this point indicate, guys? Recognize on the internet.
You can use it to access private resources over the internet.
Recognize on the internet means what? So globally unique, right? Address.
In the organization.
Little bit spelling wrong, guys. Please try to manage it. Try to focus on the technologies which I'll try to explain you guys. Don't focus on my spellings. You understood me, guys? So how many people are aware of IANA, guys? How many people are aware of this on IANA? Anybody know about IANA? Clara? Isaac? How many people are aware of this one, guys? Guys, are you there, all of you?
Yes, I'm available.
Okay, what is that, guys?
I don't remember the whole acronym, but it's an organization that deals with IP assignments and manages the IP addresses that are publicly assigned.
So what is the long form of IANA? Very good.
The Internet Assigned Numbers Authority.
Yes, very good. Internet Assigned Number Authority. So this is one of the American organizations. They manage all these your public IPs, and your public IP is not a free of cost. Okay, you have to pay money for it. These are the internet connections. It is a globally unique and registered IP address. We'll also call it as your static IP address. Okay, so given you have to pay for the services from the IANA or to the IANA, we have to pay for it. Understood, guys? This is the difference between your public IP and your private IP address. I hope it's clear, guys. Any questions here? And as usual, this is used inside the organization, and it is given by your network engineer or administrator, or it is a unique within the organizations. Okay, not recognized on the internet, free registers. So these are all the globally recognized. When you take the ISP internet connection, especially the lease lines, okay, they will take a lot of documents, guys. So they will take a lot of documents. I think IP addressing, regarding IP addressing, I told you already now. And remember this one, NAT works on RFC 1918, guys. 1918 RFC, and NAT defined for RFC 3022. We have to remember this. So now, what are different types of NAT that we shall discuss now? NAT types. Anybody have the idea about different types of NAT? So types of NAT. Static, right? Dynamic. Then
Reverse.
PAT, port address cancellation. That's it. Then how does these people work, guys? How these people works? So types of NAT. So first one is Static NAT, second one is, and third one is PAT, port address translation. Okay, if you want, I'll write it down long form. Okay, so let's discuss how does the static NAT is going to work. See, the static NAT is how it is going to work. Okay, it is one-to-one communication, guys. Remember, guys, so as I told you that before, your public IP is not a free of cost. You have to pay money for it. Okay, so just imagine, so you have the routers. Okay, so one-to-one communications. Say example, this is your router. Okay, which is you want to communicate for your ISP, that is your internet. You want to communicate, so maybe I think you are using some public IP, say example 100.1.1.10. Okay, you are using some IP address. So inside organizations, you are running some network inside, you're running server, PCs, all and that. So what happened? So this is, we are running, this is your 1.124. This is your 1.1 PC. When they want to, when you configured with the static NAT, okay, it will use this IP address and go out and access the internet. What about these guys? This guy cannot access because, you know, you are using only one IP address. Understood, guys? Until unless this guy has done the communication, has done the internet access, this guy cannot access the internet. This is called your static NAT. I hope you understood, guys. One-to-one mapping, guys, between your private IP address to your registered IP address. This is called your private IP address. This is private. And what is this IP? This is your registered IP address or public IP. One-to-one communication. Now, how does this guy works now? Dynamic NAT. How dynamic NAT is going to work? Okay, in dynamic NAT, it will create the pool. Okay, that will call NAT pool. So here, so you'll be having, say example, let's say 200.1.1.10, 1.11, 1.12, 1.13, 1.14, 1.15, 1.16. So means we are creating around 7 IP address. We are creating the pool of network. Say this is 1.2, 1.3 IP address, 1.4, 1.5. Remember, this network is different and this network is different. So it will create the pool of network. How does this work is, any one of these free availability IP address where this will be available here. This table, any one of the IP address it will take. So let me write it down. I'll remove this. I would have write this table here. This is my NAT pool. So example, this is my 100.1.1.11, 1.12, 1.13, 1.14, 1.15. So it goes like depending upon, maybe you are taking 10 IP address. So any one of, it will take any one of this IP address and communicate to the ISP. That's it, guys. It will take any one of this IP address in the pool. It will select and go and access your ISP, that is your internet. Understood, guys? In dynamic NAT, okay, it will create the pool of IP address. We need to purchase this one. We need to buy this 10 IP address from whom? From ISP. Okay, so it will take any one of the IP address in the pool and it access this IP address. Your NAT is going to convert it. Your NAT, it will convert to this IP address, which is free available IP address in the pool. It will access that IP address and access to the your ISP. Understood, guys? This is how your dynamic NAT works. So what is PAT?
You explain about the dynamic IP, please.
Dynamic IP?
Yeah.
You want me to explain once again?
Yeah.
See, what it does means, first thing is it will create one pool. This is your dynamic NAT. So here it will create your NAT pool.
Okay.
Say example, okay, this is your router. So where you are running some network. Okay, say example, this is your PC. Here we are running network like 192.168.1.0 network /24. So this is your 1.2. What kind of IP address is this? This is 1.4. So he's trying to access your internet. The public IP, so what you have taken, say example, you have taken 200 dot, okay, 1.1.1. So in NAT, you have to buy, okay, you can buy 5 or 10 depending upon, like if you are a rich guy, you can buy more public IPs. That is your static IP. So here it will create the pool 1.1.1, 1.2, 1.3, 1.4, 1.5, and 1.6. When any one of these guy, okay, is trying to access the internet, okay, it will check which is the free available IP address available in my pool. It will select any one of this IP address and access the internet. Same thing. If 1.3 want to access, okay, so it will select any one of this IP address and access the internet. Same thing. So right now, so I have the 6 IP address here. So 1, 2, 3. So we'll be connecting 1, 2, 3. What about 7th guy? 7th PC. So example, this is 1.10. This guy will be put on wait state because is already full. The pool is full. Pool is occupied by these PCs. 7th PC has to wait until unless this guy has done the communication from internet access. Understood, guys?
Yes.
Okay, this is how your dynamic NAT is going to work. So let's discuss how this PAT is going to work. So PAT has got some good advantage, guys. Okay, say the same scenario I will take. So let's take, this is my router. Okay, so this is, say example, this is connected to my internet. So I will take 200.1.1.1. Okay, so you know you have the network, so which lot of PCs connected. So you are running 192.168.1.0. So what it does means you need to buy only one IP address in PAT. port address translations. So inside what it does means, so using single IP address, say this is your 1.2, 1.3, 1.4, 1.5, and 1.6. So what it does means, if anyone want to access, it use only single IP address. It use only single IP address, but it will add the port number. Okay, it add port number. Say example 40724. Okay, it will convert this IP address and it will say you are a public somewhere you will be communicating some web server. Inside you have some web server. So web server IP address is example 170.1.1.1. So this IP address it will convert 170.1.1.1 with the port number 80. When this guy 1.1 want to communicate, if 192.168.1.1, it will take this IP address, it will add this port number, and then it will communicate to this web server. Web server might be your HP, like www.hp.com or dell.com, any website. Same thing, this guy. It uses the same IP address and the port number change again here. Same IP address, 200.1.1.1, and here port number will be 4725. Same thing here, port number. IP address remains same. Okay, 4726. Same, 4727. So each PC can use this IP address, same IP address, only the port number get changed. I hope this understood, guys. At the same time, all people can access this web server. This web server, all people at the same time. Maybe you are running 1,000 PCs at your organizations also, they can use one single IP address. That is the advantage of your port address translation. I hope it's clear, guys.
We can just come back a bit on the port address transition.
See what I'm trying to explain here. So let me, so where you are not understood, tell me first.
Like when buying the public IP
Okay.
for the.
Okay, you are going to buy this one. Okay, this is your public IP, that is internet, right?
Yes.
This is your public IP. Okay, you can buy only one IP address, you configure with the pad in your router, which is connected to your organization inside network. Maybe you're running 1,000 computers in your organizations. This all PCs 1,000 IP address can communicate with a single IP address to communicate your internet in pad. Thing is only it will change your port numbers.
So where would the port number be changing from the devices we are using?
Yes.
I mean
that is the job of the router. Router will do that job.
So the router will be the one assigning the port numbers.
Yes, it will assign the IP address, the port number. The IP address is same, 200.1.1.1. Okay, and port number 40725 and 726. Keep changing.
Does it have a limit?
Yeah. Sorry.
I'm asking, does it have a limit, or it can assign as many as port
Yes.
numbers it can?
It has no limit. So as per this thing, I think 65,535 can generated by one router. That is sufficient. Correct.
That is clear. Yeah, that is clear
Yes.
now.
Yeah. Can you jump for the lab now?
Yes, please.
I think lab is quite very interesting.
Before we go to the lab, what are
Mm.
the limitations of PAT? Because if
one IP can be used over 6,000 times, 65,000 times. Why should we choose NAT instead of PAT?
Why we should use PAT instead of NAT? See, this is a part of NAT with overload. NAT with PAT, network address translation with the ports. First, understand here. Okay. NAT is a one type. This is the one of the type of the your PAT. Right now we discuss static, dynamic, and PAT, right? Port address translation. So in static, one-to-one communication.
Yes.
Okay, whereas dynamic is not one-to-one communication. We'll be having the pool of IP address. Right? If any one of the IP address is free, it will take that IP address and communicate to your external world. Maybe
Yes.
and this is your ISP. Whereas PAT, okay, we cannot buy this full of IP address, right? As you know that internet is not free of cost. We have to pay money, right? Right. That's the reason what we are doing. So we are using the PAT, port address translation. What we'll do, so we will take one IP address, say example 200.1.1.1, okay, from the one of the ISP. And in your organizations, I am going to configure in my router. So in these routers, maybe I'm running, say example, 200 pieces. 200 pieces. I have taken only one IP address. If I configured with the PAT, okay, so this all people use only one IP address to access the internet.
Yes.
Right. Only thing is, it will change the only add the port numbers.
Yes.
That is the 4762. We'll do the lab. We can understand better now.
Okay.
Okay. The lab is, let's
Okay.
start.
Maybe let me ask it this way.
Yeah.
In this example of parts, we are buying one IP and we're just changing the ports. Is it possible to buy 5 IPs and then changing the ports of each of those 5 IPs?
Yes, yes, we can do it because most of the organizations they will not depending upon the one ISP.
Okay.
They're not depending upon the one ISP. Remember, see, this is called the multi-homing. So what they do is, so they use one router which is connected for your organizations. Okay, they use 2 ISP.
Yes.
This is ISP A and this is your ISP B. What they do is they do the load balancing. They do the load balancing. See, your traffic generating in, say example, in your organizations, you have the 1,000 employees. Means your traffic generating will be more, right? Maybe per second, you are generating 10 gig traffic. So we can divert traffic to 5 gig here and 5 gig here. Even though the link is go down, okay, this entire 10 gig traffic will route, it will take this ISP. Maybe this ISP will go down, it will take this ISP.
Yes.
Okay, if this ISP goes down, so automatically if this ISP will be active. So this will be become your primary and this will become your secondary.
Yes.
And some organization also use 3 ISP.
Yes.
See. For redundancy, maybe they'll take one more router here. We can use this. Okay, so let's do the lab now. So lab, what I'm going to do, so just I'll use the 2 PCs. So let's take, I will take 2 routers now. So I will connect serial interface. So just imagine this is my ISP. So this is my ISP network. And this network is my internal organization. This is my internal organization. So let's write this IP address. So this is my internet service provider. This is my ISP. Okay, so I'll be using the same IP address, guys. So let's make it big for you. So I'll write the IP address here. Say example, I will write this might be my 100.1.1.1. Okay, so what should be my subnet mask for these guys? /8 can I use? This is my 100.1.1.2 /8. I'm internal network. I'm running, say example, this is my 192.168. So this time, let's say I'll give 1.0 network. I can use, like example, yeah, 1.0/24. And this is my server on the internet. We can give any IP address here. Like if you want any specific IP address, you can give that range. So what I will give my IP address. Say example, I will give 200.1.1.1. And this our IP address, I'll give 2. Okay, what is the first step we should do, guys? First, configure the IP address for this thing, guys. Someone has the questions. Isaac hasn't quit. Isaac, are you there? Some internet issue.
I'm back. Thank you, sir.
Yeah. No, just now I checked your chat box.
Okay.
For the reason I couldn't see your. Okay, anyhow. So the first thing is we should do now. Okay, so what I'm going to do, just assign the IP address. So this is my router 1. So what I should configure here, just configure with the IP address as per the diagram, guys. Okay, so what is the IP address? He has given 100. So let's give interface gigabyte 0/0/0 IP address 192.168.1.100. Okay, so 255.255.255.0. No shit. Okay, then interface serial 0/0 the address 100.1.1.1. So clock rate. Save is done, so no problem. So we'll come up so that we can do the configurations. Okay, we have to do any routing protocol, guys. So here I'm going to configure better to configure my default route. Please let me know how to configure my default routing here, guys. Here. This is my ISP router. So I'll give this name as my ISP router. So host name, this is my ISP. So gigabyte 0/0/0. So I say IP address. So what is the IP address I said, you guys? 200, right? 200.1.1. How much? I say to this thing, right? 255.255.255.0. Okay, then interface serial 0/1/0. Is there someone try to speak to me, guys? Okay, so now all the interfaces up now. So let's say I'll give manually IP address for this guy 200.1.1.1. Okay, 1.1 and gateway is 200.1.1.100. So gateway is same for other server, and this is my another server 1.2 and gateway is same. Is anybody trying to speak to me, guys? I could notice here. From this side, okay, what I'm going to configure, I'm going to configure my static default route from my organization. So any network, any mask. This is default route, right? So go via 100.1.1.2. Okay, so I am in here. I should give this one more.
Supposed to add another 0.
Yes, perfect. Okay. Okay, from internet perspective, so what I should configure? Here I configure default routing, right? Show IP route. So this guy can able to reach. So example, can I ping to 100.1.1.2? Yes. What about 200? So 200.1.1.100. I can reach, right? 1 and 2. Yes, perfect. So I can reach from here. Correct. I can communicate to these all PCs now. And these people, I think we are not given the IP address. Let's give the IP address 92.168.1.100. Think 1.2. Gateway is same. I hope, guys, you people are following me. You are understanding, guys?
I'm just trying to follow you.
Please follow me. So even I think those people can able to communicate with these guys with their server. Okay, what is IP address? 1.4.100. Check the IP address for this guy. Show IP interface brief. Is a 1.100 is my gateway. Fine. So I think 1.100. Is it correct now? One dot two. So what we should configure, guys? Anything we are missing? Clara, Angi? Okay, guys. First, remember what we have configured? We have configured from, this is our organization. Say example, this is our company, say our company example, AROUSH Solutions. So I have configured default route, right? Default route towards ISP, right? What about ISP? From ISP to your network. So they'll configure from here to here. We should configure the static routing. So that we are going to do it now. So I'll go to my router, ISP router. So IP route. How to configure static routing, guys? IP route to reach to 192.168.1.0 network 255.255.255.0 go via 100.1.1.1. That's it. Show IP route. So now this guy has learned the one network. Can you see? I think they can able to communicate. Can you see now? Okay, just simple lab we had done. We had not yet configure your NAT, guys. Right now, which lab I'm going to do now? I'm going to explain the NAT. Network address translation. Okay, I'm going to configure, that is your static NAT. What I'm going to configure now, I'm going to configure your static NAT now. Okay, guys. So let's configure the static NAT. So first, go to this router now, R1. So go to global configuration mode. So IP NAT. Okay, one more thing, guys. I forgot to tell you that. See, we have to tell to the router, okay, this interface is, we have to tell you are the outside. And for this interface, we have to tell him you are the inside. This is outside, this is the inside. The outside is one which is going to outside the ISP. Understood, guys?
Yes.
Okay.
Or it's like it is vice versa for ACL.
Yes. Same thing with the ACL, how we are configured here. Right. So here, one more thing I want to tell you. So this is called, and this network from your organization, this is my R1 prospective. This global network will call outside global. Fine. And for him, for example, this server, for this network, they will think that it is outside local. This is outside local IP address. This is inside local. This is your inside local. So don't get confused. So that we are going to configure now. So let's configure to my this router. So how to configure this, guys? So IP NAT. So we can see IP, give the question mark, it will show you list of commands. See, we can see, right? NAT configuration is there available. So IP NAT, so give the question mark. So we have to tell what you are trying to configure. I want to configure inside. Okay. Source, inside source, what are you going to configure? Right now, I am going to configure the static to map to my global IP address. Okay, that is by static. So what is the static I'm going to configure? So he's asking the IP address, inside IP address, which IP address you want to communicate. So let's say any IP address, what is the IP address for this one? I will take this 1.2. So 192.168.1.2. should communicate with which IP address? This is your ISP IP address, guys. Remember, say example, this is the ISP connection what we have taken. Okay. So what is ISP connection for this one? 100.1.1.1. Okay. Same thing, same IP address, I say 3. And same thing, I will use 4. Okay. Means these 3 people, I want him to access my internet. This PC. PC 1, 2, and 3. These 3 PC must access this all my internet web servers. Now we have created the NAT. We have to go to the interface, especially gigabyte 0/0. We have to tell them IP NAT, you are inside. We have to go to this interface. We have to tell them you are inside. Okay. Same thing. So gigabytes serial 0/0, tell them IP NAT, you are outside. Understood, guys?
Yes.
Okay, so now we have to check the connectivity now. So let's see how we can do this. So let's ping to one of these server. Ping 200.1.1.1. So we do have the reachability now. We do have the reachability. Now, how to check the NAT now? How to check the NAT, guys? Show IP NAT. Show IP NAT statistics. So we can see 5, 3 has been matching. Guys, please, everyone is mute, guys. I'm getting somewhere news. I don't know who is. Okay. So IP NAT translation. We can see, guys, this is quite very important to understand here. See, so what we did, we used the ICMP. Ping command we have used, right? So ping is a protocol which ICMP is ping is a command which use this ICMP protocol to check the connectivity between the two source to destination. So inside global is your ISP internet connection. Can you see? And inside local is we have ping from 1.2. Can you see? Right. So now outside local is 200.1.1.1. Outside global is 200.1.1. So right now we have ping with only one IP address. Understood? The problem with the static NAT is simultaneously we cannot do the communication at the same time. Let's say. So what I'm going to do, I'll use ping -t. Okay, -t command not work here. So -t continuously. So what I will do at the same time, I'll also ping from here. So 200.1.1.1. We are getting reply. Okay, this IP address is different, right? What is IP address of this one? This is 3. That guy is 2. So let's check this one. Show IP NAT translation. Can you see it is increasing? But thing is, okay, so at the same time, we can see this 1.2 IP address which is continuously pinging. It will keep on increasing. If you keep on checking that one, it is keep on increasing, guys.
What about the second one?
Yeah. Even if you ping from this side, say example, I'll simultaneously So I'm going to ping with the same all the IP address. So right now, only one time I ping for this one. So let's say I'll ping continuously. Let's say I'll ping -T with other IP address 200, 201.2 with this guy. Let's say continuously this guy ping, and this guy also I'll ping to -T 200.1.1.1. Now everybody is continuously they are pinging. Let's check the NAT translation now. It's increasing the table, right? See 1.2, 1.4, 1.5. So what did you notice, guys, here? Only one guy can communicate. See 1.200.1.1. Sometime we are getting reply for 1.2. When I ping from 192.168.1.3, it used this IP address, okay, to communicate to this server. This is the server IP address, right? This is my server IP address. Got it? See, same thing here. Only two people right now. See, is replying only from two servers. He's replying server only for one server for one IP, and another server is for one more IP. At the same time, we cannot communicate. This table will keep on increasing. See how much is increasing. Understood, guys? So let me stop
I have
this.
a question, sir.
Let me stop this. Yeah, man.
Outside the go after 200.1.1, there's a semicolon that's 90, 80, 96, 90, 85. What is it?
Which one? You're talking about this IP address? 192.168, this IP address?
No, the second one, 200. On the right one.
This is the server IP address.
Yes.
This is all the server IP address.
What is the number next to the save IP address? Is that port?
Yeah, these are port numbers.
Okay.
See, this is not the port number, guys. This is the sequence number. What you are seeing here, this is the sequence number, not the port number. See, port number means this is the web server, right? So you should type only 80 for all, right? It's showing the sequence number. Okay. So what I should do here, let me clear IP NAT translation. Give the question mark. Give hasty. Okay, show IP NAT translation. So now it is empty now. Because just I just clear this one, guys. Understood, guys? All of you? NAT means only one guy can communicate at the same time, not simultaneously at the same time. See, all people are communicating with the one PC, right? All two, all of you. You can see right here. Only one guy can communicate. That is, we will call it as your static NAT. Okay. So let's jump for your dynamic NAT.
Before you go to dynamic, how does load balancing work on static NAT? For example, you have 3 or more ISPs. how does static NAT work if you have 3 or 4 ISPs? Or how do you balance the load? Since it's nothing, I mean it's static. Let's say when one ISP is down, how can you go to the other when it's static to the other ISP?
That is called redundancy link, redundancy ISP. So once links go down, so that can be configured on your router itself. You can configure that, no problem.
You can configure
like load balancing is not possible here.
Okay.
Yeah, that is a separate topic. If you are using one more ISP this side, okay, so this is ISP A and this is your ISP B. Okay, maybe you are running another network here. Say example, this is 3.24/24. Fine. So this traffic we can map to this ISP, and this network we can map to this ISP. Okay, or else, okay, here you are running, say example, 100 PCs, and here we are running, say example, 100 PC. Okay, 50 PC you can divert traffic here, 50 PC you can divert traffic here. Same thing, vice versa. 50 traffic this side, 50 traffic this side. If links goes down, still these people they can go and access this ISP. This is called, we will call it as your multi-homing. Understood, guys?
Not clear.
Okay. So let's to verify this. Many things we can do it, guys. Right now we are doing just ICMP. Okay, so let's jump for dynamic NAT. So how do we configure dynamic NAT? So I'll just remove these, guys, for the things we configured. So how to remove? Do show run. I want to remove this all. Copy, paste. I'll remove this all. I think 1.3 also and 4. Correct? Okay, 2, 3, 4. Okay, 2, 3, 4. Perfect. Okay, then rest of the things are okay, no problem. So now I am going to configure the dynamic NAT. Okay, guys, you want me to send this file, right? I forgot to export this command, guys. Nobody remembered me. Guys, all of you there, or I hope nobody's sleeping.
I'm sleeping, sir.
Pawan, you are sleeping.
No, sir.
No.
I'm not sleeping.
Guys, you should ask me, right? I should send me this file for you, right? I didn't export this all commands. I removed the command. Nobody remembered me. Means you don't want this file because you want to learn yourself, right? That is a good spirit. You learn, guys, no problem. Okay, let's configure this one. I'll change to dynamic NAT. Anyhow, I'll remove this already, the configure specification configuration on that. So let's configure the dynamic NAT. So how do I configure the dynamic NAT? Same command, no difference. So here we should use the access list. We have to permit the internal network to access the ISP. So how do I access? Access list. Okay, I say 10 standard access list. Permit my network. What is my network? 192.168.1.0. And give the wildcard mask. First permit my network, then IP NAT. Okay, create the pool. Give the question mark, it will ask you the pool. Okay, I will create the pool of IP address. I will create some bunch of IP addresses I have taken from the ISP. Say example, I will take 3 or 3 IP address, means 3 internet connections I have taken, means 1-to-1 connection. Okay, so IP NAT pool. So example, I say CCNA. Okay, so what is my IP address? 100.1.1.1. Okay, give the question mark. Okay, so if you remove this IP address, say example, it asking starting IP address. Where I should start? My starting IP address is 1.1.1. Okay, give the question mark. And ending IP address. So ending IP address is 100.1.1. Say I say 5. Means I take 5 IP address. I created a pool of 5 people, 5 IP address. Then give the question mark, net mask. So what is my net mask? 255.255.255.0. Then IP NAT inside source list. What is my list we have given? I think 10. Full CCNA. This is what we have created right here. Full name. The full name is CCNA. That's it. So how do we implement? I think same command. So go to interface gigabyte 0/0 0/0/0. So IP address. So what is IP address? We can IP NAT. You are the inside. Okay, so I think we already given serial 0/0/0/1/0. So IP NAT, you are outside. That's it. So how do I check this one? So let's ping from this side again. So I'll ping to this guy though, and with this PC, I'll ping to say 20 continuously. Timeout. We have given this. Yeah, this guy is getting reply. Can you see why he's getting timeout, guys? See, now you check the translation, show IP NAT translation. We can see, right? Dynamic NAT. So here the port number are different here. So I am going via inside global is my this IP address. Inside local I have ping from 1.2. Outside is 200.1.1.1. The same number. Your NAT will getting translated. This is the dynamic NAT. See, sometime it's taking 1.3. Okay, some PC IP address 1.2 means 192.194 1.4. It using 1.3 IP address to communicate to my web server. You understood, guys? So let's ping to this PC now. So this guy is continuously pinging. So let's say I also ping this guy as well now. Let's see. So why this guy is not pinging us? Show IP NAT. Show IP NAT statistics. Net mask, starting IP address, and 10.5. Means we have taken how many? 5 IP addresses. Bunch of IP address. Guys, you are following me. What I'm trying to explain is getting translated. Perfectly is working. Dynamic NAT. We have created the 5 IP address, guys. Same thing, guys. I think DHCP, how you configured. From network, you have to authorize these are the networks I want to response to my network when they request the ARP request to my router, DHCP server. Same thing. If you type here, show IP NAT translation, so it's getting translated. We can see right now I am using 192.1.2 IP address to communicate to my this IP. Okay. 1.2 and 1.4. 2 IP address. Let's see what is the IP address. Why this guy is not communicating? This 1.3. Let's see. Ping to because those guys are already occupied. That's the reason this guy is not getting a reply. So what I'm going to do, let's stop these people. Even this guy also pinging. So let's check this guy now. There's something missing of this IP address. So these people can be able to communicate to that guy, to my web server. We are getting a reply from this guy. And there is something problem is, what is IP address for this guy? IP config 1.3. So can he ping to his gateway? 192.168.100. So we do have the reachability. Say 100.1.1.1. Yes. 200.1.1.1. Check the IP address. It's correct. We are getting translated, guys. We are getting translation from this PC. So let's say I'll ping this time 2. Okay, now we can see the translation part again. So now I can see I have pinged from 1.4. 3 times. To ping to my 200. This network. Understood, guys? This is called, we'll call it as your dynamic NAT. I have created the pool for the 5 IP addresses. So whichever IP address is free, it will take that IP address, it will communicate to those PCs. Guys, you understood me? Like if you want, yeah. So if you want, we can configure this in other in a different way. Even you can configure the telnet, we can access your server. That also we can do it. Then we have to create your username on in that. You know, right? How to configure the telnet, all of you. So this is my ISP router. I think username, say example, I'll say the Pawan. So the privilege level, I'll use 15 secret. I'll use Cisco 123. Okay, line VTY. This also we can configure. We have to generate from telnet traffic here. So password is Cisco 123 login local. So let's see, can we able to do the telnet? So what is IP address for that one? 100.1. Think 200. Yes. So Pawan Cisco 123. Right. So I can able to access show IP route. So let's see now translation. Can you see, guys? It's happening. So what do you have noticed, guys, here? Who will tell this answer, guys? I have generated the telnet traffic now. Previously ICMP packet, right? So now it is TCP. Your telnet is your TCP traffic. So who will tell this? What difference we can see here? I have done this one, right? Telnet. It is getting translated, right? See here. This is the IP where I have done the telnet. Okay, from my PC. This is my internal network PC. This is the outside local IP for address for 200.1.1.100. Okay, what I did telnet. What is the port number for telnet? 23, right? We can see the port number 23 right here. This is the port number for your telnet. I hope understood, guys. Okay, so I will send you this command, guys. Otherwise, I think even I have not saved this one. So this is my dynamic NAT. Let's export this. Before I jump for the next lab, okay, so I will send you this file right away, guys. You want this file or not, guys?
Yes, we want. So.
Please send that.
Okay, so I'm sending this. So please check from your side. Yeah, I think you received it. So now I will take the same topology and I will do copy and paste. And this I'll make it for,
So
yeah.
the purpose for NAT is only translating, whether it's
Yes.
static or dynamic, is only translating.
Yes.
Okay.
Yeah. So same lab, guys. So what I will do, just I'll remove my previous configuration. Then I will do it my pat. So what I should remove, show, run. Okay, so I must remove these all things. I say copy, go to global configuration mode, no, and paste. Pull in use, cannot destroy. Why pull is in use? Clear IP NAT translation. Why is showing this? NAT in use. So no IP NAT pull CCNA. Cannot destroy. I want to destroy. Guys, what I will do, okay, so I will give this command, okay. Now I'm going to do this one pat, guys. Okay, let me change this. So this is my pat. Let's write in caps. Port address translation, but I want to destroy is not allowing me to destroy this. So CNAT, what is the first command? This is also important, guys. How to remove also. Yeah, so now I think it's removed. Show IP NAT. Show IP NAT translation. Yeah, it's done. Now it's removed now. If you type show run, so I don't think so. So these are the things is there. IP NAT, one dot mask. Okay. I think now I can able to remove this. Let's remove that. So now it's removing. It's removed everything. Okay. So now no translation working. So now I'm going to configure your which one? PAT, port address translation. Let's check once again. Yes, everything is removed now. So now I'm going to configure the PAT configuration, guys. So how does PAT is going to work? So I'm using one IP address, only the port number get changed. That's it. Let's do that. Okay, access list, already we are configured with the access list. We have permitted one of the network just to communicate your internal network to access the IRP. It means just we are permitting your 1.0 network, your organization network to access your ISP. Okay, so let's go to global configuration mode. So what IP NAT? Okay, so here also we have to create the pool. Okay, so we can give the pool name. So I'll give same as CCNA. Okay, then so I'll give my public IP 1.1.1. So this is a static IP address. If you give the question mark, it asking the starting IP address. You understood, guys? It asking the starting IP address. Of course, here it asking the pool. Okay, in the pool we have to take the bunch of IP addresses, maybe 5, 10, depending upon how many IP address internet connection you have taken in your organization, guys. So right now, what I'm going to do, I am not going to do that. Okay, so IP NAT full CCNA. I use capital. So I use this only one IP address to be accessed to use this one IP address to access my internet. Ending IP address. So what should be my ending IP address? Ending IP address also I will give same. Okay. Then net mask. So net mask is will give all the bits are high this time. All bits are high. So now IP NAT, okay, that is inside. So which one? Inside network, inside source. Okay, which is the list? So what list we have created? List name we have not given. I think 10, right? Previously we have given, I think. IPNAT 10. Okay, then give question mark. We can give the interface name also, guys, no problem. Interface name also we can give. Because you know, what is it, this 10 indicate, guys? This is the your this one, guys, access control list. This one. Don't get confused why I'm giving 10 there. Okay, then full name is CCNA. Okay, here is asking, okay, overload. Please take overload. Use only one IP address to communicate all these guys to outside the ISP network. Overload. That's it, connection. And same thing, go to interface, gigabyte 0/0/0/0. So IPNAT, you are the inside. So then interface 0/1/0. So IPNAT, you are the outside. That's it. Show IPNAT. Right now, there is a no translation. So show IPNAT statistics. No. Still, there is a no translation. So how do we generate now? So generate some telnet traffic from inside the LAN. Say example for 1.1, 1.2, 1.3. Okay, and just ping from just do some internet access or ICMP. Okay, what I'm going to do now from NAT, from the pad, guys, from my this PC, I am going to access my web browser. That is port number 80. Okay, in this single IP address, this all people can communicate to this all this server. Okay, now this PC I want to access to this PC. What I'll do, I'll use ping. I'll ping from my this PC to this server 200.1.1.2, and for this I'll do the web browsing, and from my this PC I will do telnet, which is port number 23, and this port number 80. Let's see how does it works. Okay, so first thing is here I should do what? I should do the telnet. So telnet to my server, my router 2. So telnet, what is that? 200.1.1.100. So Pawan, Cisco 123. Okay, so I can able to access my router. All right, so telnet, I can able to access it. From this side, I must ping to my this server. So 200.1.1.2. Yes. Okay. So from this PC, I will do my web browsing. So http://200.1.1.1. Yes. So now check, we have done the 3 different types of services, right? So now you check the translation now. Show IPNAT translation. So now we can notice, guys, here. So what we did here, we can see the noticed here. So first thing is we did ICMP. Correct? We did the ICMP. So it used inside local 1.3 IP address where I have pinged. To whom I have pinged? 200.1.1.2. Okay, with this. So which protocol I am using? I am using ICMP. Understood? Now, so again, I have pinged from 1.4. So here, again, I have ping from 1.4 to this 200.1.1 with the port number 80. Can you see? The port number 80. That is www. Correct. Now, again, I did these two are TCP traffic, right? So again, what I did telnet to 200.1.1.100. That is a port number 23. What is the port number 23? Is your telnet. Your port number is 23. Guys, understood? All of you?
Yes.
Pawan,
Sir.
unnara miro?
Yes, sir.
In full tired.
No, sir. No, not that.
What about Asma? Asma, are you there? Okay, you understood what is this PAT? Clearly understood, guys. This is very important. This is the most big people, like if you face an interview, so they will ask this PAT and ACL. It's very important.
Sorry, sir. Who is responsible for configuring NAT?
Network engineer.
ISP,
Network
engineer.
ISP, how? He will not do anything for you. ISP people, they will not give, they will give only internet connection. That is your responsibility being your network engineer.
Okay.
You are the responsible for that.
Okay.
Any questions you can ask me, guys? NAT PAT I did today. Is it quite interesting, right?
Yes, it is very interesting.
So you can see this is one. This is my telnet I did, and this is my HTTP traffic. HTTP traffic I generated, and I generated my ICMP traffic. Okay, let me send you this file as well, guys. So I think already I have saved it. So let me send you this command. So what is the file name? So PAT. PAT text file. Guys, everything I'm sending you, I don't know how many people are doing practice. Okay, so be ready. I can put anytime assessment. You want assessment, guys?
Yes.
Yes,
Yeah.
please.
You are ready to do the assessment? So I have sent both the files, guys. I think you can able to. Okay, do you want this file as well? I think these are the few topics which I explained. So do you want this topic, this one, guys?
I think it is important for us to give us, for you to give us, because it helps to revise.
Okay.
Yeah.
So I will save these. as NAT. I think you received it, right, guys? All of you?
Yes.
You got
You're
them?
sending through mail or WhatsApp?
I've not received, I didn't even receive the dynamic NAT one, so I don't know.
Dynamic NAT.
Through chat.
No, there is nothing in the chat.
No, there's nothing on the chat.
Even as my saying she did not receive.
Really? No problem. I'll,
Yes.
Just make sure you're not sending to one person on the two.
no, I'm sending to all. No?
No, we haven't received.
Okay. Okay, I think and previous, did you receive it? So previous, I have sent many this thing, right?
I've only received, I think, the first two. If it's not the first three you sent,
I
but
think
the rest.
Isaac received. I haven't received.
Yes.
Oh, okay. Isaac,
Yes.
Received.
man, why you are selecting direct? Don't select direct in the chart. The other reason the other people cannot see. Anyhow, I'm sending once again, guys.
Okay.
Yeah, so dynamic NAT. So now we can see, right? Can you check now?
Yes.
And
Yes, we
Pat?
got it.
regarding Pat,
Dynamic but not dynamic not.
what about Pat? So if you want Pat also I'll send you.
Got it.
Good but up.
Okay, so any questions, guys? You can ask me. Okay. So let's talk about next topic, guys. Can I start? Next topic.
Yes.
Shall I continue next week?
You failed to send the list of topics.
Next topic, I want to start IPv6. Okay, so IPv6 and routing protocols. Using IPv6. Same thing. What are the things we did? Static, default, EIGRP, OSPF.
Yeah. Hey.
Okay, after this, then I'm going to start your switching. Still a lot of topic, guys. And this is next week.
Finish all of these.
Yeah, this all will be your next week. Okay, this all protocol, just we have to use instead of IP address. So I think we did a lab only for IPv4 right now. So instead of this all IPv4 addressing, so we have to use just IPv6 addressing. So this is how many bits? 32 bits, right? IP addressing. And this is 128 bits. That's it. Configuration remaining all are same. So I think this I will do it in just one day. Maybe I think next, I think 1st April is next Saturday. I can complete this all. Then I will jump for your switching, maybe Sunday.
Okay.
So next Sunday, I'm going to discuss this switching part. I will start switching. Switching is still more interesting as. If you have any question, you can ask me, guys. Before I could stop this training, because any questions, guys? No questions.